Welcome to Homework Lib.
We're interested in finding the probability of an electron with 8.52 electron volts of energy occupying that state in a metal that has a Fermi energy of 8.5 electron volts. And we're working at room temperature, which means that the temperature is approximately 300 Kelvin. So the first thing we need to consider is that we're dealing with electrons. So electrons are fermions, meaning that no two electrons can occupy exactly the same energy state. As a consequence of this, we need to use Fermi-Dirac statistics, which means that the probability of a given electron occupying some energy state is given by this formula here. So the first thing we should calculate is the difference in the energy of the state we're interested in, which is 8.52 electron volts, and the Fermi energy, which we are given as 8.5 electron volts. So this quantity, E minus EF, is simply going to be given by E minus EF is 0.02 electron volts. So the discrepancy between the energy of the state we're interested in and the Fermi energy tells us, in some sense, how probable it is that an electron is occupying some state. Now we need to divide this value by K, which is the Boltzmann constant, times the temperature, which we're given at room temperature. Being careful with our units, keeping in mind that we know the value of the Boltzmann constant and we know the value of temperature, we can convert this into units that are convenient to use. And since our energy is in electron volts, I suggest that we use units of electron volts as well. This quantity kT comes out to be 25.7 millielectron volts. So now all we have to do is plug in numbers. We have E minus EF, we divide that by kT. That's the value of our exponential here. We add 1 to that, and all that is in the denominator. Plugging in numbers and being careful with our calculation, we find that the probability of an electron occupying the state is approximately 0.31, or equivalently 31%. And that's our answer.